just put in a mean casserole and it's on the slow cooker, and hopefully it tastes really good. I was thinking I could make a cooking video if enough of you spam my email telling me I should. Today we're going to look at some problems that look a little bit nasty, but in both cases they have symmetry that you can exploit to solve the problem. So, problem 8. Find the value of this expression. It might be you might be looking at it going, it looks kind of similar to the assignment question. Hopefully some of these videos are helping you with that. Alrighty. Hopefully you've had a go at that. Okay, the first thing is, if we take the expression, the thing that we're trying to find the value of, and multiply it by 2 sine pi over 11, then we can use the double angle formula repeatedly because we're introducing the sine cosine factor that the double angle formula has. So if we do that, it looks like an absolute mess, but when we do it once, we get this factor here, which we can turn into sine 2 pi over 11, and then we've got the double angle formula appearing again, but without the 2, so we need another 2. So if we double both sides of this equation, we've got a 4 on the left. We've now got the double angle formula factor again, so we can convert it into sine 4 pi over 11. We're missing the 2 again, put another 2 on the left-hand side, making 8, double angle formula again, and you get just right down to the last step where we don't have angles that are double. So we don't have like the 8 and the 8 appearing again. So it looks like we've lost sort of the chain that we were doing. But sine 3 pi over 11 is the same as sine of 8 pi over 11 because of the symmetry of the sine function. So we can turn the sine 8 pi over 11 into sine 3 pi over 11, and then we can play the same game again. Put the 2, so double both sides, so we've got a factor of 2. Use a double angle formula. Again, it looks like the pattern stopped when we get to 6 pi over 11 for the sine and 5 pi over 11 for the cosine. But the sign of those values are the same, so we can interchange them, do the double angle formula again, and eventually we get down to on one side having sine pi over 11 and the other one having sine 10 pi over 11, but they are the same value. And then divide both sides by sine pi over 11 and divide both sides by 32, and you're left with the thing you started with that you're trying to find. Alrighty, one more example on that. For this one, again, it looks a little bit messy, and it comes out to be a relatively nice value. Solution: if you're careful with how you pair up the terms in this, so we put the 7 pi over 16 with the pi over 16 and the 7 pi over 24 with the pi over 24, that's what we color coded in, and then we can use the product to sum formulas on the formula sheet. When we do that, we get these cosine pi over 2, cosine pi over 4, cosine pi over 3. They're all just numbers that we know the values of. And the only thing we've left with is the sine 3 pi over 8, cosine 3 pi over 8 thing. We use the double angle formula on that. And a bit of messing around, you guys can work out kind of where this working's going, and that gives us the answer. Alrighty, your extension problem is the hardest one yet. Hardest one in this PowerPoint. Okay, give that one a crack, and if you want the answers, like any of these problems, you can just send me a message as well, along with all that spam about Mr. Walton doing cooking shows. See you later.